main focus right now. Just so you guys know, after we kind of go through this Ferris wheel equation, we're going to almost do the same thing. We're going to do the same thing using some temperatures. And eventually, we're trying to get you to a point where you say, okay, I'm getting this. Okay, like, you're starting to make the connections. So listen, because there might be some things that you say that you did correct, and there might be some things that you now understand how to do correctly. That's our goal, that we're getting you closer to that. Okay, a lot of you did think about this yesterday, but if you didn't think about the amplitude of the graph, it's still the measurement from the midline. It's the distance from the midline, but it's also the distance from the middle of the circle. Are you making a little connection with that? It's the same as the radius. So the amplitude is 25, and again, that is the same as the radius. Now, the period is the amount of time that it takes to go through a full cycle. It does take 30 seconds to go through a full cycle, but I want you to realize, as some of you asked yesterday, that a period no longer has to be a degree. It no longer has to be like 360 degrees. In fact, a period can be measured in any unit. In this case, it's measured in seconds. But it should make sense that that's the amount of time to do one revolution. And that's what a period has always been since day one. So 30 seconds, yes, 30 seconds is the period. Now we're going to take these numbers, we're going to start thinking about the equation. This is kind of like the main thing. And again, I like that you guys tried it. Some of you are going to say that you only made one mistake, and some of you, there's maybe a little more that you have to fix. But first of all, let's talk about that period. In other words, let's talk about finding the K value. Okay, now listen, the period formula, it hasn't changed, and this is good news. It's still 360 over K. Yes, you still use the same formula. That means you still can plug in 30 for the period and set that equal to 360 over K. And that means that you can divide. And when you divide, you end up getting the K value of 12. Okay, the K value of 12. Sometimes students aren't sure if you're allowed to mix and match numbers like this. Yes, I'm mixing 360 with the number 30. And when I mix those together in that formula, I get a K value of 12. And that is all okay. Now, the other thing you have to do is you have to think about the shift. You have to think about the shift. And this is actually a little tricky. Although I gave you a hint, the shift is still going to be C over K. Okay, so we're going to solve for C. But really, the reason this is a little tricky is because we got to go back to the graph and we got to think about where is the shift point. Now, I did give you a little hint. If you just take that hint as a starting point, I told you that 7.5, comma, 29 is the shift point. So 7.5, comma, 29 is the shift point. But why? Why? There's two good reasons why. First of all, it's on the midline. And as you guys are going to come to know, the midline always contains your shift point. Now, the reason the midline always contains the shift point is because that's the way the original sine wave was designed on day one. Do you remember the original sine wave? It looks like this. It hasn't changed. It's a graph that passes through the origin, and that point, that origin, is our shift point. Now look at that a little more closely with me. It's on the midline. It's always been on the midline. And I also want you to look at that graph and realize that the graph goes up. And because the graph goes up from that starting point, we can make the same conclusion down here about this shift point, because the graph is on, the point is on the midline, and the graph also goes up. Okay, so 7.5, comma, 29. That's an important point. It's the shift point. Do you realize that that then represents the shift? Like I can actually plug in the number 7.5 for shift. Yes, I can plug in 7.5 for the shift. Now, notice I'm not plugging it in for the letter C. Notice that I'm solving for C. But you've always done it this way. You've always set up that formula and then solved. Okay, I guess what I'm saying here is you just have to trust it because it works even in an application problem. We get C equals 90. So the shift, it was that point. And specifically, it was 7.5. Now, there's one more shift going on here, isn't there? There's a vertical shift. And the vertical shift, well, that is the midline. The good news is we found the midline from the last step, but I want you to realize that 29 is the vertical shift. And some of you said 4. It's okay, you were thinking, but what I want you to realize is that it's the midline. It's the midline. The number 4 was actually the bottom line. It was the bottom. Okay, and then you take all this and you make your equation. Please understand that your equation is going to use everything that we came up with. It's going to use the amplitude of 25. It's going to use the K value of 12. It's going to use a shift of, it's going to use a C value of 90. And then it's going to use a vertical shift of 29. So we have 25 sine of 12x minus 90 plus 29. Now, that's not easy stuff, but what that shows is how we can connect many things in this chapter. And so I want you to keep getting closer to that. I want you to keep getting closer. And in sort of the spirit of getting closer to making these connections, we're going to now do what we call a regression. Okay, before we flip to this, make sure you understand that it's like the same thing that we did. I'm just officially calling it a regression, okay, because a regression is really the process of coming up with this equation. Okay, that's the paper you picked up on your way in. Are you ready to flip to it? Keep the computer handy. We'll get to that in a moment. We're actually going to do some just regular pencil paper thinking. Now, the kind of thinking that we're going to go through here, okay, is known as a regression. If you want to fill that in that little paragraph at the top, I want to skip to that sentence and kind of cut to the chase here, because the process of fitting data to an equation, that's known as a regression. Again, the process of fitting data to an equation, that's known as a regression. All right, now I told you kind of at the beginning of the year, I like to be an honest teacher, and this is tough stuff. I mean, this is putting it all together, but I do think you can do it. Okay, you just have to try. I think that's what you're doing, and let's keep learning. Let's keep getting closer to understanding how to come up with one of these equations. Now, instead of doing a Ferris wheel, we're going to do temperatures. Okay, they're temperatures in Philadelphia, so that's kind of close to here. And that's a perfect example of a sine wave, because basically they go up and down. And when things go up and down, and they do that in a period, we have what's known as a sinusoidal or a sine wave. You're going to need to just take a few moments and just graph that data. So I'll be quiet and just encourage you to graph those 12 temperatures. As you graph them, you should start to kind of see a sine wave. You're going to start to see things that go up and down. Now, because this is not a perfect circle, because it's not a perfect Ferris wheel, your graph is not going to be perfect, and that's also okay. Instead, what we're going to really do is we're going to come up with a best fit. We're going to come up with a best fit. for these points. But it is going to feel similar to what you did with the Ferris wheel. Once you graph your 12 points, I actually encourage you to try to draw a best fit. But you have to understand that that doesn't mean you're like just connecting the points. It more means that you're trying to make a smooth sine wave that models the overall pattern. Okay, now the sine wave that you draw might look a little different than your neighbor's, but I still want you to draw it. Try to draw a sine wave that basically fits those points. It is not going to be perfect. That's why this is known as a regression. Now, for the next 10 minutes or so, we're going to analyze this thing. Okay, that means we're going to try to come up with the amplitude, the period, shifts, with the goal of coming up with an equation. Are you tracking with me here? Our goal is to come up with an equation. Okay, now it might feel a little bit like the Ferris wheel. There's actually a couple things I'm going to show you that are slightly different than the Ferris wheel just to help you to keep growing. Okay, but when you're ready, we're going to begin with the amplitude. The amplitude. Now, it's a little harder to just look at this graph and come up with the amplitude. To be quite honest, I don't even like to just look at the graph. And so I'm going to suggest a formula that I actually showed you back on day one, like 3 weeks ago. But today's kind of the day where we actually use the formula, and you'll find out that it's awfully nice, because there's a formula for amplitude. Maybe you remember writing it down. If you don't remember writing it down, you might want to recopy it. It's a really easy formula, and it works every time. It's max minus min divided by 2. Again, max minus min divided by 2. That's the formula for amplitude. And it works really nice in this problem because I can just take my maximum temperature, which is 86, subtract the minimum temperature, which is 38, do a simple subtraction, do a simple division, and we end up with the amplitude. I want you to realize what's happening here when you subtract these numbers. When you get 47.5, that's the distance between the top and bottom of this graph. Okay, and if you think about it, if you take the distance between the top and bottom and you cut it in half, well, that's another way to think about amplitude. Okay, so it makes good sense, and it's also correct. You get 23.75. Next, we're going to talk about the period. Now, the period, yes, you could look at the graph and you could kind of think about point to point. You've done that before. However, you can also appeal to some common sense. I don't mean that in the wrong way. I just mean you can think about the data, which is temperatures in a year. And you just have to kind of ask yourself, how long does it take to go through a cycle of temperatures? How long does it take to go through a cycle of temperatures? Well, the answer is 1 year. We're just going to write that in months. So the period is 12 months. Once again, the period does not need to be measured in degrees. In fact, in this case, it's measured in months. All right, now here's the thing. 12 months is the period, but you have to use that to find the K value. Now the K value comes from the same formula, 360 over K. I want you to start to get familiar with this again, and I want you to trust it because it works. This means that 12 equals 360 over K. And so this means that you can solve for K with a simple division to get 30. All right, so again, we can solve for k with a simple division, and we end up with 30. All right, we're on our way here. We are doing a regression. Okay, but we arrive at the horizontal shift. Now, the horizontal shift, did you kind of notice in the Ferris wheel, it was maybe a tricky part of the problem because it required us to find the midline. Now, the midline, I don't know if I can just look at this graph and come up with that. Instead, I'm going to give you guys a structure here to think about the midline with some numbers. Follow this with me for a second. Sorry about the distractions. What I'm actually going to do is I'm going to drop down according to my amplitude. Take a look at this arrow I'm drawing here. I'm going to drop down according to my amplitude with the hopes of getting to my midline. Now, the amplitude was 23.75. The amplitude is 23.75. And if I drop down by 23.75, I should be able to arrive at that middle point. Okay, but that's going to require us to start at 86, which is the maximum, and subtract 23. Do you realize what I'm doing here? I'm actually using the amplitude in a backwards fashion, backwards from what you guys are used to seeing. And this is okay. This is a legitimate way to arrive at the midline, which is at 62.35 to be exact. 62.35. Now, that's important stuff. Like, I would draw that midline if I were you. Draw 62.35. See it. Notice that it is in the middle. And the real reason that I'm having you do this is I want you to notice this purple point. You see, folks, that purple point, that's the shift point. Okay, because that's like the original y-intercept. Remember, the original y-intercept is always on the midline. So grab that point, like identify it. It's at 463. It's at 463. Now, you got to notice what I did there. I kind of took advantage of the fact that that point was already plotted. And so there's no reason to like reinvent it. It's already there. It's the number 4. Okay. And if you're like, yeah, but it's not exact. No, it's not exact. It's at 63. My midline's at 62, but that's pretty darn close. So there's no reason I can't take the number 4 and use it as my horizontal shift. Now, it's important. You guys realize it's the number 4 that's the horizontal shift, not 63. Okay, so it's the number 4 that's going to help me get my C value. Because remember, shift is always equal to C over K. So for this problem, that means that 4 is equal to C over K. Of course, we found K in the last problem. Hey, once again, we're using the same formulas. We're using the same formulas that we used at the beginning of the chapter, even though it's an application problem. So we get C equals 120. Again, good stuff. This is good stuff. In fact, the vertical shift is the midline. So there's no reason to reinvent that. We can just say that the vertical shift is at 62.35, something that we found a couple steps ago. We just did a regression. Okay, I don't know how excited you are about that, but that's good stuff. We did a regression. We came up with all the values that make this equation. So record your equation. Okay, it's y equals the amplitude, sine, and just like you try to do at the Ferris wheel, we are plugging in each of these values into this typical sine equation. By the way, it's shifted to the right, so please use a minus 120. You did all that hard work, so please use a minus because it's shifted to the right. All right, now I want to make sure you understand that what we did was correct, or maybe we should say it's as best we could do. But we are now going to allow Desmos to do the same thing, and as you probably won't be surprised, to do it very quickly and also to do it exactly. Okay, now I'm suggesting that you use a computer. For those of you that sometimes use a phone app, it'll work, but it's just easier to use a computer because you're going to be doing some typing. So figure that out, and I'll meet you over here at desmos.com/calculator. As you get this fired up, again, we're going to do the same thing, or we're going to let Desmos do the same thing, but it's going to do it exactly. Now, I have the steps written on your paper. If you're the kind of student that likes to kind of tinker around, you can work ahead, but basically we're ready to show you the same thing right now. So this is down near the bottom of your paper. The first thing we need to do, number one, is it says you have to use the add item feature to insert a table. Now in the upper left-hand corner, there's this plus sign. That's how you add some of these special items. Table is right in the middle. Okay, it makes a little X1, Y1 table where you're basically going to type in your data. Now, there's a little shortcut that Desmos lets you use. If you type 1, 2, it starts to pick up on the pattern, and I can just hit enter. I can actually just hit enter 12 times, and I'll get the numbers 1 through 12. Okay, it's just a little shortcut with Desmos. It picks up on the pattern, and you don't have to type every one of those numbers. You do have to type in the temperatures. Okay, now you just type it in these 12 months of temperatures. We would like to see them. The reason we don't see them is because we need to also adjust the settings. Okay, be careful about this because sometimes this is like the only thing that kids don't understand, but it's just a matter of thinking about the numbers you typed in. So in the settings gear, a place that we've been before, you do want to change it to degrees. You can do that whenever you want. But here's the part you got to think about a little bit. The x-axis is supposed to be the months. Now, the months went from 1 to 12. We could straight up type in 1 to 12, but you'll find out that I like to see a little bit of negative. I just like to see that side. And I'm going to go to 14. I'm going to go -2 to 14 for the x-axis, just because I like to see a little bit more. And it's kind of the same thing with the y-axis. It's the temperatures you typed in. I like to see a little negative, so I'm going to go -10 to 100. I'm going to go -10 to 100. Ultimately, you're changing your x and y axis to match the data so that you can see your scatter plot. How are things looking for you? Okay, it's the same thing that you graphed by hand. Listen, step 2, this is the main step. This is the one that might even ooh and ah you a little bit. What we're going to do is we're going to calculate the sine regression equation. Okay, now to do this, you're going to use the tilde key. The tilde key is probably around the upper left corner of your keyboard. You may have never typed it before, but if you look at the way I wrote it out, it's y1 tilde. Tilde is, again, in the upper left corner of your keyboard. And you can just continue to type exactly the same thing I have printed on the paper. Again, you're typing y1 tilde a sine of k x1. By the way, the sub 1, it just shows up automatically. As long as you type the number 1, it'll call it a sub 1. Again, you're actually typing in the same formula that we've used throughout this chapter. But look what happens. That's the tilde key. It's just right here. look what happens. It creates the equation. Why is that not working? Just maybe hit X and try it again. I'm not sure, but if you type it again, maybe it'll like it. Now, do you realize that the numbers that it's pumping out, those are the same numbers that we slaved over to come up with this regression equation? You're missing the sub 1s, y sub 1, x sub 1. You just have to type the number 1, it'll make it a sub. Okay, the numbers that it came up with, go up to your table. They're x sub 2s. So make your tilde equation x sub 2 and y sub 2. And I guess we basically would just copy them down. But I want you to notice it's a equals 24. It's k equals 25. It's c equals negative 97. Those numbers represent the best fit equation. And again, we would need to jot them down. And I usually recommend you just jot them down to like 2 decimal places. 2 decimal places. So 2405, that'll work. And then you can copy them off the screen, but please know that I am really just taking them straight from Desmos as the magic numbers that make up this equation. Hey, they're close. They're close to what we found a few moments ago. That's good, okay? That means that what we found was also a good job. It's just that these are the exact numbers that would make the best equation. There's one more number in this chart. Maybe you're like, what is that? It says r squared equals 0.98. R squared is a coefficient constant. Okay, you would learn about it in a statistics class. I'll tell you in 10 seconds, I'll kind of give you the 10 cents answer. The closer r squared is to 1, the better your fit. So r squared equals 0.98. That's really close to 1. That means our equation fits really good. Okay, that's really good. Instead of saying that it fits really good, what we can do is we can compare it with the one that we actually slaved over. What I'm doing is just typing in the equation that we found so you can see how it is very similar. You wouldn't really have to do this, but it doesn't take long to type in that equation, and I can see that my red line is a lot like the one that the computer found. If you look at the bottom of the paper, there's a second question. I'm kind of at the very bottom. By the way, the first question, how do the equations compare? Good. You could say good or close. Okay, I want you to understand that this is a good job. But the second question is a little more specific. It says, could we make a prediction about May 15th? Now listen, May 15th would be like the 5th month, and it'd be halfway through the 5th month. That would be like the number 5.5. What I'm suggesting is that we have this really nice graph. Why couldn't I trace to 5.5? Okay, because 5.5 would represent May 15th. And look, you can get a temperature. Looks like it's about 76.7 degrees. Thanks for telling me. You guys missed, then you didn't see what I did there. I typed in the equation. Let me just backtrack here real quick. I typed in the equation that we found and just kind of looked at it and noticed that it's close. Okay, it was close to what we have. And then, thank you, Donovan. If you trace your graph to 5.5, that would be the same as May 15th, and you get 76.7. What is going on? Maybe I just not meant to show you that. One more time. If you trace your graph, is it on? Okay. If you trace your graph to 5.5, that represents May 15th. So that'd be a nifty way to use your equation to make a prediction. This is good stuff. This is pretty powerful stuff. We've taken this whole chapter and tried to tie it up. We've also used Desmos to do some of the same things. And did you catch? It's really a matter of just typing that tilde, using that tilde button to allow Desmos to calculate those numbers. Okay, I want you to know how to do that. I also want you to know how to do the problem, as we sometimes say, by hand. And that's what we did at the beginning of the lesson, where you're just coming up with the amplitude, the period, and so forth. And now the back of the paper is going to sort of put you to the test. It's going to kind of let you explore these ideas one more time. It's actually 3 more times. This is an important assignment. It's something that I hope that you find some satisfaction in, and that you also, try to get correct. I'm actually going to give you a work period tomorrow. I want you to have class time because of the nature of this to work through this. Now, you could look at it tonight. Some of you might. If you look at it tonight, there is something else that you could do tomorrow to keep working ahead. But if you choose to come back tomorrow and just kind of pick up with these 3 problems, that's fine. I'm going to give you time to do that. There's one typo on that Ferris wheel table. So I don't know, did you already start typing numbers in? All you got to do is delete it. But you see in the middle of the table, there's really sort of one data point that looks like an oddball. It's just a mistake. 1.2, 100, kind of right in the middle there, 1.2, 100, just cross it out. It's just completely wrong. Do not type in 1.2, 100. Okay, now understand that the assignment is going to be a mixture of Desmos and a mixture of just some good thinking. Okay, so don't rely on the computer for everything. But if you just kind of follow my steps, I sort of guide you through. You're welcome to start now if you want. I guess there's, how much time do we have? I don't think too much, but okay, so we'll call those 3 questions back there an important assignment.